So testing of hypothesis is part of statistical inference. And statistical inference has actually two things. One is estimation, another is testing of hypothesis. Yeah. So I think someone must have covered estimation part. Estimation means you want to estimate something. For example, what would be the cost of this banner? You can guess it. So if you guess it, it is not an estimation. You must have some idea of statistical procedures, and if you use those procedures, and with the help of those procedures, you guess something scientifically, it is estimation. Estimation is not my part. I'm not going to discuss that. What is testing of hypothesis? So can anybody tell me who will be going to next Prime Minister of this India? Next Prime Minister? You will have some idea. Okay? At least if BJP wins. But if BJP loses this election, you would not have any idea. So if you tell me, you must have a hypothesis that this party will win, this party will not win. So what is hypothesis? Hypothesis is any statement. Whatever you write down, that is your hypothesis, your personal statement. But we are not interested in your personal statements. Okay? We are interested in those statements which comes from some experience. For example, if there is a doctor, he experienced something in his 15 years of practice, and he says that I think this is the case. That is this hypothesis which we want to test. Okay, and that is known as researcher's hypothesis. Researcher's hypothesis means which you guess with the help of your experience of theories or with whatever else. So I am going to discuss how we convert this researcher hypothesis into statistical hypothesis. Okay, and how we test those things, and what are the basic elements which are required to understand for the testing of hypothesis. So I start with an example. Actually, I will cover 2 to 3 examples just to discuss the variety we have. So all of you know that this kind of thing is there, that there is a controversy. Controversy means if you stay with electromagnetic field, for example, if your house is in the electromagnetic field area, then people say that there is a high chances of cancer. Patients may be there. So that is the idea. So one researcher is thinking whether this statement is true or not. That means whether there is any impact of electromagnetic field on a person so that the person can get cancer. That is the idea. Okay. So what that person or that researcher will do? Of course, number one, that researcher will find an area which is near EMF, number one, and that she will or he will survey that area to get how many cancer patients are there in last 3 years or last 5 years. Okay. Now, this is the observed value. So in this example, if you see on the last line, there were 32 such cases of child cancer. So see that there was an area near EMF, and last 3 years there were 32 cases. Now this 32 is irrelevant for you because you don't know anything about that. So what a researcher should do, she then visited a government public health library. Why? To get some data from previous studies or previous experiences or previous surveys. Now she get that there was an average of 16.2 of this similar kind of community. Now we have two numbers with us. One is 32, which was the direct observation. One is 16.2, which was from the previous study. Now question is very simple. Is the discovery of 32 cases of childhood cancers significantly large enough. See, mathematically, 32 is larger than 16 point. Mathematically, there is no problem. But statistically, whether it is larger or not, we want to know that. So we are saying that significantly large enough. Significantly large enough means we want to talk about statistically, not mathematically. In comparison with the average number of 16.2, for the researcher to conclude, okay, if it is larger, researcher can conclude that there is an impact of EMF. Okay, or it is just by chance. So there are two possibilities. First one is there is an impact. Second one is you have got data of 32 just by chance. Okay. Second example. And this is a social example. You know that we have now advanced in medical things, and there is a now it is illegal, but there are ultrasounds by which you can easily verify the sex of the child which is going to born, and you can misuse it. One can misuse it. Okay, so this example is from that context. What it says, there was a study, researchers Booth and others in 1994, they have what they have done, they have collected some data from Punjab, some data from hospitals of Punjab, or basically one hospital, and they have observed that 56.9% of 550 live births that year were boys. So there were 550 births and almost 57% were boys. So it is usually that should be 50-50%, but actually there are medical evidences that this is not 50-50. This is actually 51-49. This is more than 50. That is medical evidences are there, but this is 57. Now they have again searched in that area that what should be the baseline, that means what should be the on an average possibility. So that they have got 51.7%. So now you again see the difference. There is 57% and there is approximately 52%. Now there is a mathematical difference between these two numbers, whether they are having statistical difference or not. If there is a statistical difference, then you can say that something is illegal. Something is illegal. Maybe they're in that particular hospital. Okay. So the question is again the same. Is there evidence that the proportion of male births is different for this hospital? So these are two examples, and we as a researcher wants these things. We want to know, does the use of cell phone is associated with developing brain tumor? ये बड़ी एक कॉमन बात है. सेल फोन मत यूज करो, यहाँ ना रखो, वहां ना रखो, ब्रेन ट्यूमर वाली प्रॉब्लम. सेकेंड, आर ओल्डर वर्कर्स मोर लॉयल टू अ कंपनी? द बिजनेस पर्सपेक्टिव. थर्ड वन, डज कोवैक्सीन, अभी आजकल चल रहा है, डज कोवैक्सीन कोविशील्ड इंक्रीज द रिस्क ऑफ हार्ट डिजीज? ये बड़ा हॉट टॉपिक है. Has the median age in India increased in the past 10 years? Or is the global temperature increasing? आपको पता है आजकल क्या चल रहा है. Now the last one. Did the Cadbury ad कुछ मीठा हो जाए? ये ऐड आने के बाद क्या कैडबरी कंपनी का सेल इंक्रीज हुआ? ये कैडबरी जानना चाहेगी आपने. So these are the questions, and there are many questions like these which we want to assess with the help of scientific method. Okay, all these comes under the testing of statistical hypothesis. Okay, now first thing is researcher's hypothesis. So I have already told you that a researcher hypothesis is a statement of what the researcher believes be the outcome of an experiment on a study. For example, if I focus upon first, does the use of cell phone is associated with developing brain tumor? So this, if you want to access this question, you must have a belief that brain tumor has an impact of, cell phone has an impact of brain tumor. If you think that there is no impact, you will not perform study. Remember, if you think that there is no impact, you will not perform the study. What is the use of performing that study? Your researcher hypothesis is that I think there will be an impact. So verify whether it is or not. In second, older workers are more loyal to company. Company may think this like this way. थर्ड वन, कोवैक्सीन कोविशील्ड, क्यों ऐसा क्यों हो रहा है? थर्ड वन क्यों हो रहा है? जब लोग मर रहे हैं हार्ट अटैक से, तो लोगों को लग रहा है कि उस कारण से है। हो सकता है वो कारण न भी। Okay? So these are the, from these questions you can easily guess what is the researcher hypothesis. Okay? Now this is actually motivates us for research, because when you have a question, then you only research. Otherwise, you will not research for anything. Now, what is a statistical hypothesis? Once you have a researcher hypothesis, we want to test this researcher hypothesis scientifically. आप लोग लिखिए नहीं, सब हम दे देंगे। इससे कुछ मत लिखिए, कुछ और लिखना हो लिखिए। ठीक है, ये स्लाइड हम आपको दे देंगे। If you want to write down anything else, you can write down. Okay. So scientifically, we want to test this researcher hypothesis. But if you want to test something scientifically, what is the difference between scientifically and not non-scientifically? See, if there is something scientifically, this is an objective kind of. That means if I do, I will get the same result. If you do, you will get the same result. If that person do, he will also get the same result. So if you want to test something scientifically, you have to convert those statements in such a manner that there will be no ambiguity. So we want to convert those researchers' hypotheses into statistical hypotheses. And what are statistical hypotheses? They are actually the same statement written in terms of some mathematics or some parameters of the population. There are parameters. For example, what is the average age of persons in this room? So average age, I do not know. So that is a parameter. What is the median age of Indians right now? That is a parameter. Okay. So what is the average income of India right now? That is the income per capita. That is a parameter. So those parameters, if you write down your researcher hypothesis in terms of the parameters, that is a statistical hypothesis. Okay. And we want to test statistical hypothesis. Remember, I am discussing testing of statistical hypothesis. Okay. So when you test a statistical hypothesis, what you are going to do? अभी हम और सर वैसे बात कर रहे थे, सर ने क्वेश्चन बोला, एक बात बोली कि स्टैटिस्टिक्स इज ब्लाइंड, क्या ऐसा है? तो किसी दूसरे फैकल्टी ने जवाब दिया, जैसे कानून अंधा होता है वैसे स्टैटिस्टिक्स भी ब्लाइंड है। व्हाट डज इट मीन? सी, इन स्टैटिस्टिक्स we don't put our opinions. Okay, we will collect data, and with the help of data we will find whether the hypothesis is supportive or it is consistent with the data. Okay, so we are going to find whether our data is supporting the hypothesis or not. We are not going to find whether the hypothesis is true or false, because you cannot find that. If something is in nature, you cannot exactly find the truth. So we are just going to guess the truth with the help of data. Okay. Now we want to guess that scientifically so that everyone can get same. The last line is very important. To test the statistical hypothesis, we must decide whether the hypothesis appears to be consistent with the data in hand. Because if you have some data, hypothesis is consistent with that or not. इसका सबसे बेस्ट एग्जांपल जो हमको लगता है, सबसे बेस्ट if there is a person who is charged of murder. Okay, so what would be the hypothesis of judge? So if I assume that judge thinks that okay, that person is innocent. So now if data produces like that, there is a pistol and finger, there is a pistol जिससे हुई है और उस पिस्टल पे फिंगरप्रिंट्स हैं उस आदमी के. There is an eyewitness who is also saying this was the person. Do you think that this data is consistent with the innocence hypothesis? Not at all. So that is I am saying. Consistency means whether your data supports the hypothesis or not. If your data is not supporting the hypothesis must be discredited. That is the idea. So what is null hypothesis? Now we come into the statistical hypothesis, and we know that we have to convert our research hypothesis into some kind of a statement which depends upon the parameters. Then what is the null hypothesis? So I again take another example to discuss it. So it says that there is a tobacco firm and it is producing some kind of tobacco, and you know that in tobacco there is a nicotine, and with the help of that tobacco they are producing cigarettes. अब लोग सिगरेट लेंगे, निकोटिन जाएगा. कंपनी इतनी अच्छी है, कह रही है कि हम एक ऐसा प्रोसेस डेवलप करेंगे जिससे निकोटिन कम हो. इतनी अच्छी कंपनी, कम से कम सोशल कॉज कुछ तो सोच रही है. So what they are saying that they are claiming that we have developed process which says that there is a nicotine on an average less than or equal to 1.5 milligram. Okay. Now a researcher like me or like you may be skeptical कि नहीं यार कंपनी तो ये सब नहीं करती है. So skeptical means what is researcher's hypothesis? Researcher hypothesis is clear that company's claim is false. What would be the researcher's hypothesis? It would be that mean nicotine is greater than 1.5 milligram. That is the researcher's hypothesis. Okay. Now remember, whatever your hypothesis, that means what you want to prove, because researcher want to prove it. So that you take the complement of that as null hypothesis. Why? Because researcher wants to discredit the statement given by the company. So a statement given by the company will be the null hypothesis. Remember, a statement given by the company will be the null hypothesis because researcher wants to discredit it. So what is the null hypothesis? In a simple language, null hypothesis is that hypothesis which we want to test for possible rejection. Okay? कुछ लोग कहते हैं null means जहां पर null हो, मतलब equal to हो, same. That is also if it is taking care of whatever is right now, that will be the in future. So that is also null. The simple thing is the null hypothesis will be that hypothesis which we want to test for possible rejection. So this person, this researcher wants to reject the hypothesis of the company. Now you think that this may be a biasness. As we proceed, you will find that this is not a biasness. Okay. So in language, we say that mean nicotine is less than or equal to 1.5 milligram. In mathematics, we write it's not mu less than or equal to 1.5. And what is mu? Mu is the parameter. That means this is the average nicotine in the population. That is the parameter. So I have converted that hypothesis into parametric version, and now it is a statistical hypothesis. Okay. So after writing down your null hypothesis, and if you reject it, what would be the conclusion? So you must have an alternate hypothesis. Because if you reject something, you have to decide something else. So that will be the alternate hypothesis. So in this case, the alternate hypothesis will be mu greater than 1.5. Because your null was mu less than or equal to 1.5. The other side is mu greater than 1.5. This is the researcher's hypothesis, which is being converted into the alternate hypothesis. If you see it carefully. Okay. Now, recall this example of EMF. We want to write down the hypothesis in that case. What was the observed was 32, reported was 16.2, and what we want to test? That there is an impact of EMF. So if I write down the null hypothesis, I am writing in language, we can convert them into mathematics without any problem. There is no effect of EMF on childhood cancer. This is the null hypothesis. Now, no effect. This can also resemble with null hypothesis. So we want to reject it. We want to discredit it. Because researchers thinks that there is an effect of EMF. So this is the null hypothesis. Now, what is alternate? See, I have said that alternate means when you reject it, you are going to conclude. So here we have three possibilities. Here we have three possibilities. One is there is an effect of EMF. There is an increase. See, first one says there is an effect. There is an effect means it may be positive and negative. Both. There is an increase and there is a decrease. So common sense says that you should go for not for at least decrease. With our experiences is EMF के पास रहने से कैंसर कम हो जाएगा अगर ऐसी कोई टेक्निक आ जाए हम सब वहीं जाके रहने लगे. So if you choose H1 double star as an alternate hypothesis, this will be full skyrocketed. So the best is H1 star. But if you do not want to go to H1 star, you can go to H1. That is not very good. H1 star is the best one. Because this was your suspicion before the observation. Now, I am going to discuss very important thing. What is the first line? There is an effect of EMF on childhood cancer. That means what you are saying that there is a childhood cancer, this is the result, and there is an EMF, this is the cause and effect. Okay. What was the experience? What was that person has done? उसने सिर्फ इतना किया था, वो गई थी 3 साल का डेटा इकट्ठा किया तो चली आई. When you do these kind of things, these are known as observational studies. These are known as observational studies. In observational studies, remember that you can never find cause and effect. So all these four are actually wrong. All these four are wrong. Because my study was observational and I am claiming that there is an effect of EMF on childhood cancer. So all these four are wrong actually. The right version is this. There is no factor affecting the childhood cancer. You do not know that EMF is the reason. We can only say that there is no factor. And there is some special factor. That some special factor may be EMF or maybe anything else. ठीक है. So observational studies में अगर आप इस तरीके की ऊपर वाली लिख देंगे तो that is a wrong thing. ऊपर वाली लिखने के लिए experimental studies होने चाहिए. You have to perform the experiments, but that will be unethical. आप ये नहीं कर सकते कुछ को EMF के पास रखो देखे कैंसर हुआ कि नहीं और कुछ को नॉन EMF में रखो देखे कैंसर हुआ कि नहीं. That is not possible. Ethics. तो एक्सपेरिमेंट नहीं कर सकते. और बहुत सारे तरीके हैं. But remember, first four are wrong. Correct version is last piece. Okay? क्योंकि छोटी छोटी गलतियां लोग करते हैं. Now recall the second example of that male birth. So what was the male birth? 56.9. This was the observed and this was the reported. So we can write down that the reported one is staying there. तो रिपोर्टेड है पिछले साल का वही है इस हॉस्पिटल के लिए भी वही होना चाहिए. So this is the proportion. I have converted this into proportion of male births. Proportion of male births I am writing P is equal to 0.517. क्या हुआ लैंग्वेज को फिर मैथमेटिक्स में कन्वर्ट कर दिया. So now P is a parameter. जितने भी लोग वहां हैं उनका जो मेल बर्थ हो रहा है उसका प्रोपोर्शन इतना है। ऑल्टरनेट क्या क्या हो सकता है? proportion is not equal to this, proportion is greater than this, proportion is less than this. For this particular example, what should be the alternate? For this particular example, what should be the alternate? Alternate can be H1 star or H1. But recall, I have stated there, can we conclude that male birth is different from 0.517? Different, I have already stated in this statement. So the only answer is H1. So you have to find that statement which you want to. Accordingly, you have to convert these things. Okay. Now, when you have write down, you have written the null hypothesis, alternate hypothesis. Now you have a test statistic. You must have a test statistic. Test statistic means it is just a statistical tool to test your hypothesis. जैसे आप अगर फैकल्टी मेंबर्स हैं तो आप स्टूडेंट को पढ़ाते हैं, पढ़ाने के बाद एक टेस्ट पेपर देते हैं। दैट टेस्ट पेपर, उसी को हम यहाँ टेस्ट स्टैटिस्टिक बोलते हैं। टेस्ट पेपर आप कैसे बनाते हैं? जो सिलेबस होता है, जो पढ़ाया होता है, उसी से कुछ 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 क्वेश्चन सेलेक्ट कर लेते हैं। तो दैट इज अ फंक्शन ऑफ दैट सिलेबस मैथमेटिकली। Similarly, you have a data. With the help of data, you can calculate many things. For example, with the help of data, you can find mean, variance, if it is possible. Okay, those things are actually test statistics. And with the help of those things, we will decide. जैसे आप डिसाइड करते हैं बच्चा फेल होगा, कौन सा ग्रेड आएगा, ए आएगा, ए प्लस आएगा, बी आएगा, कैसे डिसाइड करते हैं? वो पेपर दिया, फिर उसका कुछ मार्क्स आया। सो यू विल हैव अ टेस्ट स्टैटिस्टिक, दैट टेस्ट स्टैटिस्टिक विल हैव सम वैल्यूज, एंड विद द हेल्प ऑफ दोज वैल्यूज यू विल डिसाइड समथिंग। ओके, सो definition I have already told you. So those values by which you decide, they are called critical reason. They are called critical reason. For example, I go back into murder case. If opponent produces my pen, for example, I am the murderer, I am the जिसके ऊपर केस लगा है, मेरा पेन वहां पे था, मेरा मोबाइल वहां पे था, मेरा जूता वहां पे था, उसका निशान था, इससे क्या मर्डर प्रूफ हो जाएगा? हो जाएगा? नहीं हो, इससे नहीं हो। क्रिटिकल, क्रिटिकल इज थंब इंप्रेशन ऑन द पिस्टल जिसका यूज हुआ है मर्डर। क्रिटिकल इज आई विटनेस। दीज आर द क्रिटिकल थिंग्स। Why you are saying these critical things? Critical कहे क्यों रहे? Because if I am innocent, these things are not possible, or these things are less likely to happen unless किसी ने पूरा जाल ना बिछाया हो हमारे खिलाफ। ठीक है? So critical means if your null hypothesis is true, what is unlikely to happen? Those values are actually critical values. Okay, because if those things happen, then you can say there's something bad in null hypothesis statement. It may not be. And if there is a critical reason, there will be non-critical reason, which usually people say acceptance reason, which is the complementary of that. So acceptance reason means रुमाल मिल गया, एक्सेप्ट कर लो, मर्डर थोड़ी किया, इनोसेंट है आदमी। पेन मिल गया, इनोसेंट है। एक्सेप्टेंस मींस which is highly likely to be there. Okay, so these two things will be there. So finally, what we are having a statistical test. So in statistical test, you have a test statistic, you have a critical reason. If your test statistics belongs to this critical reason, you reject the null hypothesis. And if it does not belong to critical reason, you do not reject the null hypothesis. I am emphasizing the statement to not reject. I am not saying accept H now. Okay. I have sizes on this. Do not reject H. Okay, why I am saying this? अगेन एन एग्जाम्पल, अभी एक रिसेंट केस था, रिसेंट नहीं काफी दिन हो गया, सलमान खान की गाड़ी से कुछ लोग मर गए थे फुटपाथ पे। यू रिमेम्बर दैट? क्या हुआ उसका? न सलमान खान को के ऊपर आरोप तय हो पाए और न उसके ड्राइवर पे। कार कौन चला रहा था मैं आज तक नहीं समझ पाया। Who was driving? So point is, can you accept the decision, but you are not able to reject it? You are not accepting it, but you are not rejecting it. Actually, so you do not reject it. So do not rejection is actually something better than accepting it. Okay. So, for example, in this tobacco example, in tobacco, what we are doing, we were interested in mean nicotine per cigarette in the population. So what you can do? You can take some sample of cigarettes and check mean nicotine, check the nicotine of first cigarette, second cigarette, third cigarette, and find out the average. So that average will be test statistic. Because if you want to perform something for the mean, find the average. Average will help you to decide about the mean of the population. Okay? Recall, there are two terms, mean of the population and average of the same data. So mean is actually the parameter kind of thing. And average I am finding here. So that is my, so I am taking, I am taking 36 cigarettes and I am fixing my standard error that uh, there will be measurement errors and many other things. So I am fixing that 0.8. And in that case, I am finding X bar. X bar means the average nicotine in these 36 cigarettes. Okay. And I found with some mathematics that the critical region is 1.72 or bigger than that. What was the hypothesis? Hypothesis was 1.5. What I am saying that if you want to say that it is bigger than 1.5, even if you go up to 1.7, there is no problem. Even up to if you go up to 1.71, there is no problem. When you get 7.2, there is a, okay. So I am saying that if you cross this border line, then reject H0. If you are unable to cross this broad border line, do not reject it. Now question arises, very simple question. How you decide about border? What is the idea to decide about border? There must be some scientific methodology to decide this border. And to understand that methodology, see these three pictures. This is 1.7. Okay. And I am assuming that there is a data which is normally distributed from where we are getting this kind of things. Now, what I am saying that I am saying if mean is 1.5, if the actual mean is 1.5, that means company is producing cigarettes having actual mean 1.5, and then you get 1.72. What is the probability of getting that? So, if you get 1.72 or bigger than that, even if the mean is 1.5, the probability is actually 0.5%. Only 5%. So there is a 5% chances that if the actual value is 1.5 and you are getting 1.72 or bigger than that, it's only 5%. So if you reject the null hypothesis, so there may be only 5% chances that you are wrong. Because if you reject it, your decision may be right or wrong. Okay. So if you reject it means you are in this area. And what is the probability of this area? Only 5%. And if you reject it, and suppose it is true, so you are committing only 5% error. Because whenever you reject it, you will be here and the area is 5%. So even if it is true and you are rejecting it, you will commit only 5% error. What is the idea? So here I am fixing 5%. Now what would happen? See, if it is 1.7, so you recall 1.72 will be on the right. 1.7, if you go on the left, probability will increase. Is it okay? So now this probability is more than 5%. So I'm not taking the risk of committing any kind of error with more than 5% possibility. Okay. Third one, if it is 1.8, instead of 1.72, it is 1.8, of course the probability will be less than 5%. Now it is again very critical. So if you move on the right side, it will be having very less possibility. Okay. So this is the idea. So that means what is important now? Important is where you are fixing the border. That border fixing is related to this probability. How to fix this probability? Next question. First, we understand the interpretation. See, when you reject something, you can relate this with that example of murder. If the judge is rejecting that I am innocent, so what will be the output? I will have lifetime imprisonment or I will have death sentence. So that output will be very, very dangerous. Is it or not? So if you reject something, then you are taking a strong decision. That is the idea. Because rejecting means there's only 5% possibility. And with 5% possibility, you are rejecting it. So there is a strong answer. Now, in the case of Salman Khan, not rejecting, judge is not rejecting. This is not a strong statement. This is a weak statement. You cannot conclude anything from this statement. You may have your suspicions. Is it okay? The same way, if our data is inconsistent with the null hypothesis, the null hypothesis will be rejected. And that will be a strong statement. And if your data is consistent with the null hypothesis, then you are not going to reject it, and this will be a weak statement. Okay? So that is the interpretation. But while doing these things, you will commit errors. You may commit errors. There are two types of error, type 1 and type 2. If you reject something which is true, that means you reject the null hypothesis when it is actually true, you are committing type 1 error. That means if I am innocent and you give me lifetime imprisonment, so you are committing an error. If I am not, I am a murderer and you are leaving me, you are committing an error. So there are two types of rejecting something which is true, not rejecting something which is false. This will always be there. जैसे आप बहुत टफ पेपर बना दीजिए, अच्छे से अच्छा बच्चा फेल हो जाए, क्या मतलब उस पेपर का? आप एक ऐसा पेपर बना दीजिए, खराब से खराब बच्चा पास हो जाए, क्या मतलब उस पेपर का? खराब बच्चे को पास नहीं होना चाहिए, अच्छे को फेल नहीं होना चाहिए. You must prepare a question paper like that. The same thing is there, type 1 and type 2 error. Now, if you see it carefully, I have already fixed type 1 error. हमने 5% वहां कर दिया. तो जो 5% था, वो बेसिकली ये था कि हम टाइप 1 एरर को फिक्स कर रहे हैं. हम कह रहे हैं कि जो सही है उसे रिजेक्ट नहीं करेंगे. सर उसे रिजेक्ट अगर करेंगे तो 5% टाइम ही करेंगे. अब आप देखिए कोर्ट केस में क्या होता है. मर्डर में खासतौर से डेथ सेंटेंस है. अगर आपने एक हिंदी का लाइफ सेंटेंस सुना होगा तो सेंटेंस है कि 1000 गुनहगार छूट जाएं लेकिन एक बेगुनाह को सजा नहीं होनी. सुना है आपने? तो वो 1000 गुनहगार छूट जाए का क्या मतलब है? और एक को सजा नहीं होनी चाहिए. डिवाइडेड बाई 1000, 0.0000 0.001, आप 0.001 उतना एरर पे आप फोकस कर रहे हैं, इतना क्योंकि डिसीजन वो क्या इम्पैक्ट लाएगा किसी की लाइफ में या कईयों की लाइफ। ओके, तो type 1 and type 2 errors are there, and the problem is we cannot fix both of them. That is the problem. If you are very strict, something will be fixed, something will not be fixed. मान लो बहुत टफ पेपर बना दिया, तो जिसने नहीं पढ़ा वो तो फेल हो जाएगा, लेकिन जिसने पढ़ा वो फेल हो जाएगा। तो आप एक्सट्रीम में नहीं जा सकते, यू कैन नॉट गो इन एक्सट्रीम्स। सो आइडिया इज both are problematic, so we fix one of them. And this is the usual technique, we fix the first of them. So we fix the upper bound of this, and mathematically we minimize the second one, and when you minimize the second one it will give you the test procedure. So whatever test procedures you are studying in statistics, they are actually based upon this idea, fixing the type 1 and minimizing the type 2 error and finding something. And that's something you know actually. You don't know the process. Okay? So objective is clear now. Objective is not to prove something. You cannot prove anything with the help of data. You can only say my data supports it, my data do not support this. I again quote the fourth example. Fourth decision कैसे देता है? On the basis of evidence, this person found guilty. Second statement, on the basis of this evidence, this person does not found guilty. वो ये नहीं कहता है on the basis of evidence this person found innocent. जज पता innocent है कि on the basis of evidence this person does not found guilty. Found guilty does not found. Lekin on the basis of evidences. So if you produce bad evidences, the decision will be bad. So obviously in Salman Khan case, Salman Khan की कोई प्रॉब्लम नहीं है, जज की भी कोई प्रॉब्लम नहीं है, एविडेंस गायब हो गए, या हो सकता है ना ही हो, उन लोगों ने ऐसा कुछ किया ही ना हो, आपके पास दो पॉसिबिलिटी। तो सेम स्टैटिस्टिक्स में होगा, अगर आप हमको मैनिपुलेटेड डेटा देंगे तो आंसर कुछ और आएगा। तो ओरिजिनल डेटा, ढंग से लिया गया डेटा ढंग के आंसर तक पहुंचाएगा, आप उसको मैनिपुलेट कर लीजिए। फिर आप ये मत कहिए कि स्टैटिस्टिक्स की प्रॉब्लम है, कहते ना देयर इज अ लाई, देयर इज अ लाई, स्टैटिस्टिक्स इज अ बिगेस्ट लाई। स्टैटिस्टिक्स इज नॉट अ बिगेस्ट लाई, वी ह्यूमन बीइंग्स आर द बिगेस्ट लाई, वी आर मिसयूजिंग द स्टैटिस्टिक्स। आप डेटा के साथ मैनिपुलेशन कर दीजिए, आंसर कर बदल जाएंगे। सो आई एम नॉट क्लेमिंग दैट दिस इज द ट्रूथ, दिस इज द फॉल्सनेस, आई एम जस्ट क्लेमिंग दैट this is the data and data sets light on this, and in the light of data this is the conclusion. Okay, आपने ऊपर कुछ नहीं लेना, और ये भी बता देना this is the conclusion with 5% of error. So level of significance which you fix 5%, 10%, 1%. Now question arises, what is the choice? Should I fix 5% or 10% or 1%? So if you recall the fourth example, that was not even 1%. 1 divided by 1000, that was below 1%. So if rejecting of null hypothesis make a big changes, recall, if rejecting of null hypothesis resulted in big changes, your alpha must be very low. Your alpha must be very low. क्यों? क्योंकि कोई चीज सही है और उसे आप रिजेक्ट कर रहे हैं और उससे बहुत बड़े इंपैक्ट आ रहे हैं, तो आपको कॉशन लेना पड़ेगा। जैसे मान लीजिए कोई मेडिकल में कोई मेथोडोलॉजी है कैंसर ट्रीटमेंट की, एंड इट इज अ गुड मेथोडोलॉजी, एंड समवन क्लेम्स दैट माय मेथोडोलॉजी इज बेटर देन दिस, एंड यू टेक द एक्सपेरिमेंट एंड यू चेंज इट और रिजेक्ट कर देते हैं आप पुरानी वाली, तो जैसे ही नई वाली मेथोडोलॉजी आएगी, देयर विल बी न्यू सेटअप्स, देयर विल बी न्यू ट्रेनिंग सेंटर्स, देयर विल बी मनी एंड टाइम इन्वॉल्व। और मान लीजिए दोनों सेम हो, तो इट इज हाईली वेस्टिंग ऑफ मनी एंड टाइम। तो उस समय अल्फा छोटा हो। ठीक है, तो अल्फा आप डिसाइड करेंगे डिपेंडिंग अपॉन योर एक्सपीरियंस। नाउ इस अल्फा से बचने के लिए लोग पी वैल्यू तक चले जाते हैं। व्हाट इज पी वैल्यू? बड़ी खतरनाक लोगों को लगती है, इसमें कंफ्यूज रहते हैं लोग। व्हाट इज पी वैल्यू? So I ask you a very simple question. If I am innocent, what is the probability of having my fingerprints on the pistol which have been used for the murder? Number नहीं बताना आपको. It will be small or high. It will be small. Okay. This is actually p value. P value means whatever data you are getting, what is the probability of getting this data or extreme of that data? ये जो डेटा मिला है इसके मिलने की प्रोबेबिलिटी क्या है अगर नल हाइपोथेसिस ट्रू है, या इससे खतरनाक डेटा मिलने की क्या प्रोबेबिलिटी? खतरनाक मीन्स पिस्टल पे फिंगरप्रिंट्स साथ में आई विटनेस, दैट इज probability of getting that kind of, if I am innocent, that is something positive, very positive number, because someone may use something जिससे हमको फंसाना चाहता हो, कर ले हमारे साथ खिलाफ चीजें कर सकता है, तो probability will be there, but it will be very very small. So if your p value is very very small, what does it indicate? It indicates that the null hypothesis must be rejected. क्यों? Because if null hypothesis is true, this gives us the probability of getting this kind of data or extreme of that. So this is actually related to level of significance. That means what is the smallest significance level at which data lead to rejection. For example, p value is 0.05%. So if p value is 0.05%, if you fix your alpha bigger than that, it is the smallest one. इससे छोटे पे अल्फा फिक्स करें, स्मॉल इससे छोटे अल्फा फिक्स करेंगे तो नहीं आएगा. आई कैन शो यू वन एग्जांपल ओवर देयर. तो डेजिग्नेशन हम आपको पहले बता चुके हैं. नल हाइपोथेसिस इज दैट हाइपोथेसिस व्हिच you want to discredit. Alternate hypothesis is that hypothesis which is the researcher's hypothesis most often and you want to prove it. Okay, so that I have already told. So now see the importance of designation of the hypothesis. Same example, same tobacco example. What was the tobacco example? Company was claiming that mean nicotine is less than or equal to 1.5, and researcher was skeptical. She wants to prove that it is bigger than 1.5. So what was the null hypothesis? Null hypothesis was less than 1.5. Alternate was bigger than 1.5. मान लीजिए सिनेरियो बदल जाता है. कंपनी कह रही है वी आर गोइंग टू प्रूव अवर क्लेम, क्योंकि कंपनी का भी R&D सेक्शन होता है, वहां भी स्टेटिस्टिशियन बैठे होंगे, रिसर्चर बैठे होंगे. कंपनी ने कहा हम अपना क्लेम प्रूव करेंगे. जैसे कंपनी ने कहा क्लेम प्रूव करेंगे, कंपनी जो नल और ऑल्टरनेट बनाएगी वो बदल जाएगी. रिमेंबर दैट, बिकॉज हमारा प्रोसेस ऐसा, प्रोसेस बायस नहीं है. प्रोसेस इस तरीके का है कि जो प्रूफ करना है. सी आप समझिए, प्रूफ मीन्स ऑल्टरनेट में रिजेक्शन तभी होगा जब बहुत छोटी प्रोबेबिलिटी हो. तो आपको बहुत रेयर डेटा मिलेगा तभी रिजेक्शन होगा, और जब रिजेक्शन होगा तभी प्रूफ होगा. तो रेयर डेटा इंप्लाइज प्रूफ. तो कंपनी wants to do the same experiment, then hypothesis will be changed. Our null will be mu greater than or equal to 1.5 now, and alternate becomes mu less than 1.5. क्योंकि कंपनी अब एक्सपेरिमेंट कर रही है. तो आप समझिए सेम एक्सपेरिमेंट में कौन इन्वॉल्व है उससे हाइपोथेसिस बदल जाएगी. ये मत समझिए बस जो मर्जी वो लिखो. Okay, summary is very simple. You will always have a parameter in which you are interested. That can be proportion, that can be mean, that can be variance, that can be anything. And that parameter, you will have some possible ranges. For example, mu less than 1.5. That will be the null hypothesis. And alternate will, it is not in that area. That will be some alternate thing. Then what you do, you find alpha, fix alpha. पहले एरर फिक्स कर लो, एक्सपेरिमेंट बाद में, एक्सपेरिमेंट देख के एरर फिक्स नहीं करना, पहले फिक्स कर लो भाई तुम्हारे एक्सपेरिमेंट में सही चीज को रिजेक्ट करने की कितनी गलती बर्दाश्त कर सकते हो, दैट यू फिक्स इट. जैसे हम लोग फिक्स कर लिया 1000 रुपए गुना छूट जाए एक को सजा नहीं देंगे, 1000 गुनागार छूट जाए तो नहीं देंगे सजा, वो फिक्स कर रखा हमने कहीं ना कहीं एक्सपेरिमेंट के पहले. सो यू हैव टू फिक्स अल्फा, देन फाइंड अ पॉइंट एस्टिमेटर. पॉइंट एस्टिमेटर इज अ टेक्निकल टर्म. टेस्ट स्टेटिस्टिक्स, that function, जैसे हमने मीन टेस्ट करना था, एवरेज निकालना था, दैट इज द पॉइंट एस्टिमेटर. डिटरमिन द प्रोबेबिलिटी डिस्ट्रीब्यूशन. व्हाई प्रोबेबिलिटी डिस्ट्रीब्यूशन? क्योंकि जो हमने एरिया बताया था कि 5% आएगा, वो बिना प्रोबेबिलिटी डिस्ट्रीब्यूशन के नहीं आएगा. बट दैट इज नॉट योर जॉब, कंप्यूटर ने सब कुछ कर रखा है. देन स्पेसिफाई द क्रिटिकल रीजन. With the help of alpha, you specify the critical reason and decide. Now, when you decide reject H naught, what would you conclude? So, conclusion: if you reject H naught, you conclude that on the basis of evidence, H1 is true. That is the conclusion. But if you do not reject it, you say that on the basis of there is no significant evidence which lead us to the rejection of null hypothesis. एटलीस्ट हमारे पास एविडेंसेस नहीं है, डेटा ऐसा नहीं कह रहा कि रिजेक्शन. कंक्लूजन भी आपको लिखने में ध्यान रखना. तो दिस वाज समरी and this was the idea of all those things which one test status or one test statistical procedure uses to test the hypothesis. Okay, now there are different tests available. There are different methodologies. First is parametric test, non-parametric test. What is parametric and non-parametric kind of thing? Yeah. Social science, if you are from social science, non-parametric are more useful. If you are from not from social sciences, so non-parametric biology में भी यूज होता है, जगह. So non-parametric ज्यादा यूज. पहले हम parametric क्विकली कवर करेंगे, फिर non-parametric के बारे में थोड़ी सी बात करेंगे. Parametric means two things. One is the statement is written in terms of parameter and hypothetical scale. The second thing is जहां से आपको डेटा मिल रहा है उसका आपको डिस्ट्रीब्यूशनल फॉर्म, जैसे हम कहें नॉर्मल है, हम कहें एक्सपोनेंशियल है, डेटा जहां से मिल रहा है उसका डिस्ट्रीब्यूशनल फॉर्म पूरी तरीके से पता है, उस पैरामीटर को छोड़ दें. तो आप पैरामीट्रिक की बात करें. पैरामीट्रिक में नॉर्मली व्हाट यू हैव द डेटा इज कमिंग फ्रॉम नॉर्मल डिस्ट्रीब्यूशन. ये ज्यादातर आपके पास रहता है. डेटा कैन बी फ्रॉम एक्सपोनेंशियल डिस्ट्रीब्यूशन, डेटा कैन बी कम फ्रॉम गामा डिस्ट्रीब्यूशन, एनीवेयर. बट व्हाट यू नो, डेटा इज कमिंग फ्रॉम नॉर्मल डिस्ट्रीब्यूशन. बट if I say that data is coming from a distribution, see, you know that normal distribution is symmetric. Okay, now if I say that data is coming from a distribution which is positively skewed, can you guess the distribution? If I say that data is coming from a distribution which is positively skewed, can you guess the distribution? Huh? Can you guess? Yes, please, yes. Positively skewed. Positively skewed. Can you guess the distribution? That I am saying. No, not at all. So you do not have information, exact information about the distribution. You have some characteristic of the distribution, that it is positively distributed, it is positively skewed, it is negatively skewed. Some characteristic you know. Then you have to go for the non-parametric test. Okay. Clear? So I am focusing upon the parametric test quickly. If you have a situation when data is coming from normal distribution and variance is known, and you are interested in mean, testing of the mean. Okay. So these are the assumptions. Here, size does not matter. Remember that whenever variance is known to you, size does not matter. Okay. If these are the cases, you just use Z test. Just use Z test. Since your data is one, for example, if I just say that the average height of the participant, average height of the male participants is 5 feet. If that kind of a statement I want to check, then this test will be there. Because you have one population, and if I know that, okay, what is the sigma exactly, for example, so you can use this. And how you use? See, this will be the hypothesis. This will be alternate hypothesis. If you are saying that mean is 5 and mean is not 5. So if you say not 5, 5 means it can be bigger than 5, it can be lower than 5. So critical reason, that is rejection possibility, is on both the sides. So here and here, both the sides. Now, if you want to commit 5% error, do not commit 5% this side and 5% this side, because that will become 10%. You commit 2.5% this side and 2.5% this side. That's why I am writing alpha by 2. So these things are there. कंप्यूटर ऐसा कर देता है, इसमें आपको टेंशन नहीं लेनी, आपको सिर्फ आइडिया समझ. And this is the test statistic. Root n x bar minus mu naught upon sigma. This is the test statistic. So with the help of this test statistic, you find things, critical region, and decide it. Quickly go through this example. A simple सा example है. कोई स्टार है, वहां की इंटेंसिटी हम मेजर कर रहे हैं with some technology, and we know that standard deviation is 4. Now it is suspected that the intensity of the signal is 10. We want to test it. So we assume that normality is there, everything. We are assuming those things. How to test? You just take some sample. So they have taken 20 times intensity. They have verified, they have measured that, and the average is 11.6. Now even 11.6 and 10, there is a mathematical difference. We want to know that whether the statistical difference is there or not. You test it, you find the test statistic, it is 1.79. Now you see, ये तो बहुत पीछे मुश्किल होगा देखना. This is 1.79 and the critical point is 1.96. The critical point is 1.96 and you are having 1.7 before that. That means you are not in the critical region. So you will not reject it. ये critical region में नहीं है. यहाँ पीछे होता तो rejection हो जाता. ठीक है. So there is a critical region. अगर आप उसके अंदर चले गए तो reject कर दीजिए, नहीं तो मत. अगर यही टेस्ट इस तरीके का होता, म्यू लेस देन म्यू नॉट, म्यू ग्रेटर देन म्यू नॉट, जो हम लोगों ने किया था उसमें टोबैको में, तो उसमें आपका एक साइड में था क्रिटिकल रीजन, वन साइड. क्यों एक साइड में था? क्योंकि रिजेक्शन करने के लिए इसको रिजेक्ट करोगे तो कहाँ जाओगे? H1 में. And what is H1? H1 is mu greater than mu naught. So you move towards greater than. So critical region will be on the one side. Okay. So the idea is very simple. If your test statistic is large and you are rejecting it, then it is on the right hand side. If your test statistic is small and you are rejecting it, it is on the left side. If your test statistic is either large or small and you are rejecting it, it is on both the sides. So there are T tests, very famous tests. And what is the change between Z and T? In Z test, you know this sigma. In T test, you do not know the sigma. So you just replace sigma by its estimator, and fortunately, the picture of T and Z are almost similar. So idea is almost similar. Okay. Again, example is not very important, but I must discuss at least one. ये आपका pH वैल्यूज हैं रेन के डेटा की, और हम ये जानना चाहते हैं pH वैल्यूज उतनी ही बनी हुई है कि बढ़ गई हैं. We want to conclude that acidity of the rain has changed from its historical value or not. So it has changed. Change means what is the alternate hypothesis? Not equal to. So alternate hypothesis is mu is not equal to 5.5, 5.2. अब यहाँ पर आप टी टेस्ट लगाएंगे, ये हमने एसपीएसएस में किया था. एसपीएसएस का ये आउटपुट आएगा. आउटपुट हम समझा देते हैं, बाकी लैब में आप लोगों को कराया जाए. दिस इज टी. This is degrees of freedom. Don't bother about degrees of freedom right now. Main thing is this: significant two-tailed 0.107. This is main. Two-tailed. Why two-tailed? Because mu is not equal to 5.2. So it may be bigger than 5.2. It may be less than 5.2. And what is significant? Actually, this column gives you p value. This column gives you p value. So what is, if I convert it into percentage, it is 10.7%. So your p value is 10.7%, means if the null hypothesis is true, that means if pH is 5.2, then getting this kind of data has 10.7% possibility. There is a high chance कि आपको उस तरीके का डेटा मिल जाए. So if there is a high chance, p is high, you are not going to reject it. So the conclusion is, so the null hypothesis would not be rejected at 10% level of. अब गलती करने के लिए तैयार बैठे हो, कह देंगे अल्फा 15% तक बात अलग. अब वो 15% तक गलती करेंगे, देन यू रिजेक्ट इट. अभी अगर आप रिजेक्ट करेंगे तो गलती कितनी होगी? 10.7%. इतनी हो सकती. इससे ज्यादा अगर गलती करनी है तो रिजेक्ट कर दो. ओके. सो पी वैल्यू ये कॉलम आपको देगा. इसी तरीके का आपको वन साइडेड होंगे, इसमें अभी नहीं जाएंगे. टू सैंपल का आइडिया देंगे, बहुत डिटेल में नहीं जाएंगे. टू सैंपल मीन्स, अब मान लीजिए यही हम चेक करना चाहें, मीन हाइट ऑफ मेल पार्टिसिपेंट्स एंड मीन हाइट ऑफ फीमेल पार्टिसिपेंट्स आर सेम और डिफरेंट, और मेल पार्टिसिपेंट्स हैव मोर ग्रेटर देन फीमेल पार्टिसिपेंट्स. इस तरीके की बातें जब आप करेंगे, अब इंडिपेंडेंस है दोनों में, मेल एंड फीमेल हाइट का कोई लेना देना नहीं. टू पॉपुलेशंस हैं आपके पास, उनको कंपेयर, तब आपके पास सेट टेस्ट लगाएंगे. कौन सा? सेट. लेकिन तब जब सिग्मा पता, डेटा नॉर्मल से हो. सी, वी हैव इंडिपेंडेंट सैंपल, वी आर इंटरेस्टेड इन पॉपुलेशन मीन, पॉपुलेशन वेरिएंसेस आर नोन, सैंपल साइजेस डू नॉट मैटर. ये सब बातें रहेंगी. तब आप अपना सेट टेस्ट लगा लीजिए. इस तरीके से टेस्ट स्टेटिस्टिक बनेगी. कॉम्प्लिकेटेड फॉर्मूला आपको लग सकता है, आप इसको मत देखिए. आप सोचिए कि एक टेस्ट स्टेटिस्टिक बनेगी, एक टूल होगा, कंप्यूटर में होगा वो टूल, काम हो जाएगा. ये आइडिया क्या है? आइडिया सिर्फ ये है, this test statistic will give you a critical region, and from critical region you will see. That is the idea. But if you change it and you say that population variances are unknown, now see, population variances are unknown, but if sample size are large, remember that if population variances are known, go for Z. If population variances are not known but sample sizes are large, again go for that. Again go for that. Okay. So, but t-test. See here, sample sizes are small. Now, population variances are not known and they are approximately same, and sample sizes are small. When sample size is small, then you go for t-test. Is it clear? Okay. So this is one of the simple example. इसमें क्या है कि किसी को अगर कोल्ड हो गया तो लोग कहते हैं कोल्ड हो गया तो विटामिन सी की गोली खा लो. किसी ने एक्सपेरिमेंट किया होगा, ये इम्पैक्ट है कि नहीं है. क्विकली करते कैसे एक्सपेरिमेंट? कुछ लोगों को विटामिन सी की गोली दे देते हैं और कुछ लोगों को विटामिन सी की गोली जैसी गोली दे देते हैं, जिससे साइकोलॉजिकली उनको लगे कि दवा मिली, जिसको प्लेसिबो बोलते हैं. सो प्लेसिबो, तो यही किया गया है यहाँ. विटामिन सी दिया और एवरेज टाइम देखा कोल्ड कब खत्म हुआ, और प्लेसिबो दिया और एवरेज टाइम देखा. अब हम ये जानना चाहते हैं विटामिन सी का इम्पैक्ट है कि नहीं. तब आप बताइए ये अगर हम ये स्टेटमेंट चेक करना चाहें, does these data prove that taking 4 ग्राम of vitamin C daily reduces the time that a cold lasts? This is our aim. विटामिन सी लेने से रिड्यूस होता है, तब आपकी नल हाइपोथेसिस क्या होगी, ऑल्टरनेट हाइपोथेसिस। आप रिड्यूस करना चाहते आप रिड्यूस करना चाहते हैं, ध्यान रखिएगा, तो नल तो होगा कि सेम रहेंगे, और रिड्यूस करना चाहते हैं ऑल्टरनेट में जाएगा, इसमें जाएगा ऑल्टरनेट। तो दिस इज आवर हाइपोथेसिस। या this is our hypothesis. Mu P stands for placebo, C stands for vitamin C, and mu stands for mean. So this is the mean time of placebo, which is less than mean time of vitamin C. तो आप क्या प्रूव करना चाहते थे कि प्लेसिबो वाले से कम हो रहा है विटामिन सी, तभी विटामिन सी इफेक्टिव है, अदरवाइज नहीं है। आपने इसमें टी टेस्ट लगाया, रिजल्ट्स आए, हाइपोथेसिस रिजेक्ट हो गई, वो सब तो कंप्यूटर कर देगा। मेन थिंग इज हाउ टू फ्रेम द हाइपोथेसिस, दैट इज मेन। अब उल्टा फ्रेम कर देंगे मामला बदल जाएगा, ठीक है। इसी तरीके से पेयर्ड आता है। पेयर्ड मीन्स जब आपका डेटा इंडिपेंडेंट ना हो, जैसे मेल फीमेल है, यहाँ डेटा इंडिपेंडेंट इंडिपेंडेंट था। पेयर्ड का एक एग्जांपल जैसे उन्होंने लिया है कार और माइलेज। नाउ यू कैन विदाउट एडिटिव एंड विद एडिटिव मीन्स, जैसे हम लोग पेट्रोल डलाते हैं, पेट्रोल में वो कहते हैं ना एक बढ़िया वाला है, बढ़िया वाला, उसमें एडिटिव मिला देते हैं, कहते हैं एडिटिव मिला लो माइलेज बढ़ जाएगा। सो हम ये एक्सपेरिमेंट करना चाहते हैं, भाई सेम कार में दोनों डाल के देखो ना, तब काम बनेगा। विद एडिटिव भी चलाओ, विदाउट एडिटिव भी चलाओ, सेम कार तो ठीक है। कुछ कारों को आपने विद एडिटिव चलाया, कुछ को विदाउट एडिटिव चलाया, तो फिर मजा नहीं आया। तो पेयरिंग करनी पड़ेगी आप, बिकॉज यहाँ पर कार का भी इम्पैक्ट हो सकता है, एडिटिव का भी इम्पैक्ट हो सकता है, तो तब पेयर टी टेस्ट लगाएंगे, ठीक है। तो इस एग्जाम्पल में पेयर टी टेस्ट लगा करके रिजल्ट आएगा, वो रिजल्ट की बात नहीं है, मेन चीज है कि पेयर टी टेस्ट लगाएंगे। तो हमारे पास अभी तक जो समरी है वो ये है पैरामीट्रिक की, कि अगर आपका डेटा नॉर्मल है, सिंगल पॉपुलेशन है, साइज स्मॉल हो चाहे लार्ज हो, कोई फर्क नहीं पड़ता, वेरिएंस पता होना चाहिए, तो जेड टेस्ट लगा। अगर साइज स्मॉल है, वेरिएंस अननोन है, टी टेस्ट लगा दो। साइज लार्ज है, वेरिएंस अननोन हो, जेड टेस्ट लगा दो। तो दिस इज द समरी of all those tests which are parametric and I have discussed today. These are some good references if you want to learn these things. I told you that this is the study of Booth. The second one is a book, and this third one is also a book. This third one is a very good book. Most of the examples I have taken from this. And for this part, thank you. I have 15 minutes left. So questions के लिए हम सोच रहे थे नॉन पैरामीट्रिक क्विकली आइडिया दे देते हैं, हाँ दे देना, थोड़ा सा आइडिया देते हैं। आप 15 मिनट वो ऑर्गेनाइजर्स की तरफ से हमारे लिए बोनस होगा। I will go because now you know idea, okay, and you also know what is non-parametric. Non-parametric means you do not have parameters involved and you do not have exact distributional form. You have some idea that it is positively skewed or it is negatively skewed or it is symmetric, even that can be there, that the data is coming from a symmetric distribution. It may be normal, it may not be normal. So those situations are there. Since these kind of things are there. We focus upon some other aspects of data. One of them is ranking. So I assume that all of you know ranking. Ranking means statistical ranking. There is a difference. If you get highest marks in your class, you will have rank 1. But in statistic, if you get lowest marks, you will have rank. So there is a difference. Remember that. So I am not going to cover all these things, obviously. I cannot cover in. Why non-parametric, I have already told you. This is data which is positively skewed. So if you have data like this, you cannot use Z-test, T-test and all those things. Because there is an assumption, clear assumption that data is coming from normal distribution. Here you cannot do that. So what are non-parametric tests? I have already explained you. While ranks, I have given the idea of rank. Median. You know median. Median is the middle value. ठीक है? इससे ज़्यादा नहीं डिस्कस करते हैं अभी. My aim is this test. One sample sign test. Now you have data coming from one single population, and you want to see that this is for a population median. See, in t-test, you are testing population mean. Here we are testing population median. It actually corresponds to t-test. And we assume only one thing, that population is continuous. This is the assumption. Population is continuous means data जहां से भी आ रहा है वो continuous nature का है, जैसे height, weight, इस तरीके की चीज है. Number of students ऐसी बात नहीं, because number of students will not be continuous kind of data. और फिर आपके पास स्मॉल सैंपल के लिए हम लोग देखेंगे और लार्ज सैंपल के लिए तो अप्रोक्सीमेशन कर लेंगे. तो आइडिया इज साइन टेस्ट. साइन मींस, see, if the median is 5, for example, you know that 50% must be bigger than 5 and 50% must be less than 5, because this is the nature of the median. So we just find out the sign of those numbers which are bigger, put plus sign, and if they are smaller we put minus sign, and if they are same we ignore them. इतना ही आइडिया है इस पूरे टेस्ट का. आइडिया सिर्फ इतना सा है कि आप काउंट कर लीजिए मीडियन से बड़े कितने हैं, मीडियन से छोटे कितने हैं. अगर आपकी हाइपोथेसिस ट्रू है, यही मीडियन है, तो 50-50% होना चाहिए ऑलमोस्ट. अगर 50-50% ऑलमोस्ट नहीं है, रिजेक्टेड. दिस इज द आइडिया. बड़ा सिंपल सा एग्जांपल है. फुट साइज है और हम चेक करना चाहते हैं दैट मीडियन साइज इज 10.25. इसमें स्पेसेस, नल हाइपोथेसिस हमारी हो गई 10.25, ऑल्टरनेट हो गई इट इज नॉट 10.25. वी अप्लाई टेस्ट using SPSS. I am skipping those things, and we get this out because we are focusing about the output and the interpretation. Negative differences means which are less than median. So there are 4 foot sizes which are below 10.25. Positive differences, there are 6 which are above, and tie is 0, a total is 10. So it would be better if I get 5-5. That would be the best. But I am getting 4-6. But you cannot say anything because you have to find the distribution, and with the help of distribution, you want to know whether these 4-6 are significantly different or not. And it says that here 0.754 rooted. That means there is a 75% chances if the median is this, you get this kind of data. 4 उसके आगे चले जाए, 6 पीछे चले जाए. 75% चांसेस है भाई इसके. ठीक है, कैन यू रिजेक्ट इट? पी वैल्यू अगर इतनी बड़ी हो जाए रिजेक्ट कर पाओ? डू नॉट रिजेक्ट इन लाइफ. एंड इफ यू डू नॉट रिजेक्ट, What will be the conclusion? There is insufficient evidence to indicate that median foot size is different from 10.25. ये लिखने का तरीका है. There is insufficient evidence to indicate that median foot size is different from 10.25. Alternate था different from 10 to 10.25. अब करो हमारे पास इतने एविडेंसेस नहीं कि उधर तक जा सके. इधर alternate. Where is sticking with this? Okay, clear? So I repeat, क्योंकि quickly गए हैं. One sample sign test, we check median, and how you check? You use the property of the median that 50% इससे ज्यादा होंगे, 50% से कम. To find out how many data points are bigger than that, put a positive sign. How many are less than that, put a negative sign, and if they are equal, ignore them. And if this ratio, this should be 50-50. So if this ratio is very imbalance, for example, 10 and 90, that kind of situation, or the p-value will tell you what is the situation. So in our case, the p-value was 75%. That means there is a 75% chances if the median is 10.5, then that will be bigger than that and 6 will be smaller. So that means this is not an unusual thing. So if this is not an unusual, why reject the null hypothesis? You cannot do that. Okay. Now this person Wilcoxon, statisticians के साथ बड़ी खास बात रही. बहुत सारे नॉन पैरामीट्रिक टेस्ट स्टैटिस्टिशियंस ने डेवलप ही नहीं किए. तो बड़ी खास बात है. नॉन पैरामीट्रिक टेस्ट ज्यादातर नॉन स्टैटिस्टिशियंस ने डेवलप किए. क्यों? क्योंकि प्रॉब्लम उनकी थी तो वही सॉल्व किए. विल्कॉक्सन वाज ए केमिस्ट. ये भाई साहब का फोटो लगा दिया हमने. ये क्या करना चाहते थे? He wanted to test similar t-test without requirement of normality. ये नॉर्मलिटी नहीं चाहते थे, टेस्ट करना चाहते थे टी की तरह. इन्होंने एक पेपर 1945 में प्रेजेंट किया. अगर आपको ओरिजिनल पेपर पढ़ना हो तो ये रेफरेंस है. इंडिविजुअल कंपैरिजंस बाय रैंकिंग मेथड्स बायोमेट्रिक बुलेटिन वॉल्यूम 1. इन्होंने ये पेपर लिखा और इस पेपर में इन्होंने अपने मेथड्स को डिस्कस किया. विल्कॉक्सन ने 2 टेस्ट दिए. विल्कॉक्सन रैंक सम टेस्ट, विल्कॉक्सन साइंड रैंक टेस्ट. नाम में ही सब कुछ कंप्लीट हो जाता है. जैसे पीछे वाले में साइन टेस्ट नाम था, साइन निकाला, टेस्ट किया. यहाँ नाम कह रहा है विल्कॉक्सन साहब तो दिए थे इसलिए विल्कॉक्सन लगा, उसको छोड़ देते हैं. रैंक सम टेस्ट, दैट मींस यू आर गोइंग टू फाइंड द रैंक्स and taking the sum, and based upon that you are finding something. The signed rank test, that means you are finding the sign as well as rank and then doing something. Okay, so see, first one is equivalent to 2 sample independent tests. You have 2 samples, you can use t-test if everything is okay. Otherwise you can use Wilcoxon rank sum test. And if there are pairing, you can use this signed rank. What are the examples? And this is important to know. Wilcoxon rank sum test, जब विल्कॉक्सन ने ये रिसर्च किया उसी समय मान और विटनी 2 लोग थे, उन्होंने सेम रिसर्च किया, सेम, और अलग अलग रिसर्च पेपर्स पब्लिश किए. उन रिसर्च पेपर्स में जो टेस्ट स्टैटिस्टिक थे they were different but conclusions are same. And later we found that those test statistics are related. तो आपको डिफरेंट सॉफ्टवेयर्स में कहीं विल्कॉक्सन मिलेगा, कहीं मान विटनी मिलेगा. एक ही चीज है, ध्यान रखिए. तो हमारा नल हाइपोथेसिस क्या है? 2 पॉपुलेशन डिस्ट्रीब्यूशंस आर सेम. जैसे हमने कहा ना, मीन हाइट ऑफ मेल पार्टिसिपेंट्स एंड फीमेल पार्टिसिपेंट दे आर सेम. इस तरीके की बात करना चाहते हैं. ये एग्जांपल बड़ा इंटरेस्टिंग है, क्विकली इसको बता देते हैं. एग्जांपल थोड़ा सा ट्रैक से हटके है, और ये है फीमेल्स जो है, हमें माफ करें, बुरा ना माने. फॉलोइंग डेटा शोज द नंबर ऑफ अल्कोहल यूनिट्स कंज्यूम्ड पर वीक बाय 13 मेल एंड 14 फीमेल. ये डेटा है अल्कोहल कंजम्पशन का. Is the amount consumed more in male than compared to female? ये रिसर्चर हाइपोथेसिस नॉर्मली होगी कि मेल ज्यादा अल्कोहल कंज्यूम करेंगे, फीमेल कम करेंगे। तो हम ये चेक करना चाहेंगे और ये हमारा डेटा है। ऑब्वियसली ये डेटा इस तरीके का रिप्रेजेंट आएगा जब आप बॉक्स प्लॉट बनाएंगे, एंड यू कैन इजीली सी दिस इज नॉट अ सिमेट्रिक डेटा, दिस इज नॉट कमिंग फ्रॉम नॉर्मल। ये आप इजीली देख सकते हैं, स्क्यूड डेटा है प्रॉपर। तो एटलीस्ट वो सारे टेस्ट पैरामीट्रिक तो नहीं। व्हाट वी डू, ये तो मान बिटवी एसपीएसएस वाला वर्क पोर्शन है, इसको स्किप। आई विल फोकस अपॉन ओनली द आउटकम। सी एल्कोहल, मेल देयर वर 13 मेल, 14 फीमेल, टोटल 27। प्रोसेस क्या है, आई विल डिस्कस द प्रोसेस। हमने क्या किया, वी कंबाइंड बोथ द डेटा एंड वी अरेंज देम in ascending order and we rank them, and we rank them. Now you see, after ranking we add the ranks of male separately and we add the ranks of female separately. Now you see, if for example males are taking more alcohol, so they will have more, they will have bigger numbers, so bigger numbers will have higher ranks, so some will be higher. The idea is just if both are similar, rank sum will be similar. If someone is bigger, rank sum will be bigger. That is the idea. So we are focusing upon mean rank or sum of the ranks. So you can see one is 207, another is 170. Obviously, rank sum of female is lower, average is lower than male. But this lower means mathematical low. Statistically lower है कि नहीं, सिग्निफिकेंट है कि नहीं, उसके लिए हम पी वैल्यू पे जाएंगे। इसमें बहुत सारी चीजें हैं, आप सब पर फोकस ना करिए। हमारा जो क्वेश्चन था that was, because question is important, our question was whether males are taking more alcohol or not. So because question was this, so this is one sided test because it is more. So from here, from all these outputs, you have to find this one exact significance 1/10, and this is 10%. 10% चांसेस हैं कि अगर दोनों एक जैसा अल्कोहल कंज्यूम कर रहे हैं तो भी मीन रैंक में ये डिफरेंस आ सकता है। तो इससे कंक्लूड कर सकते हैं क्या आप कि मेल ज्यादा ले रहे हैं? नहीं, कैन नॉट कंक्लूड दैट। कंक्लूजन इज डू नॉट रिजेक्ट नल हाइपोथेसिस, दैट मींस बोथ आर कंज्यूमिंग इक्वली। दिस डेटा सेज, आई एम नॉट सेइंग, आई एम नॉट सेइंग, डेटा इज सेइंग। ओके, now I skip all these things. Paired and non-paired data I have already discussed. Wilcoxon's clean rank test, ये स्लाइड भी हम आपको दे देंगे, आप टेंशन न, आप सिर्फ समझने पे। विल्कॉक्सन साइंड रैंक टेस्ट, यहाँ पेयर्ड डेटा होगा आपके पास और पेयर डेटा पे हमको चेक करना। सो हाउ यू चेक, सी a group of 10 patients with chronic anxiety received sessions of cognitive therapy. वो पता ना, जैसे जैसे मान लीजिए हम यहाँ पढ़ाने आए हैं, डिस्कस करने आए हैं और उससे ही हमारे हाथ पैर कांपने लगते हैं, तो दिस इज कॉल्ड एंजाइटी, और हम गिर जाते हैं, दैट इज क्रोनिक एंजाइटी। फिलहाल दोनों नहीं। Okay. So, a group of 10 patients with chronic anxiety, sessions of cognitive therapy, भी साइकेट्रिस्ट के पास जाएंगे, साइकेट्रिस्ट आपको थेरेपी देगा। क्वालिटी ऑफ लाइफ स्कोर उसके बाद मेजर की गई, साइकेट्रिस्ट ने कैसे किया आई डोंट नो, उसने ये आउटपुट दे दिया। क्वालिटी ऑफ स्कोर बिफोर एंड आफ्टर, बिफोर द थेरेपी एंड आफ्टर द थेरेपी। जैसे आप काउंसलर के पहले कोई टेस्ट करा लें और बाद में टेस्ट करा लें। जैसे अगर आपने इनका कोई टेस्ट लिया था, नहीं लिया, अगर आप सब लोग जब आए थे तब आपको एक टेस्ट पेपर दे दिया जाता है कि आपकी स्टैटिस्टिकल नॉलेज क्या है, और जब वर्कशॉप खत्म होता है तब एक टेस्ट पेपर दे दिया जाता है, तो हमें पता चल जाता है वर्कशॉप का इम्पैक्ट क्या है। आपने सुना है कि सोए हैं, हमने पढ़ाया है नहीं पढ़ा पाए हैं, तो दैट इज, so before and after हमारे पास डेटा है. Now you understand this data is paired because the first row 6 and 9 that is related to a single person, same person. मान लीजिए वो आदमी, उस आदमी का खुद की बहुत सारी साइकोलॉजी होगी जिसका इम्पैक्ट होगा, सिर्फ काउंसलिंग का इम्पैक्ट नहीं है, उसका खुद का बहुत इम्पैक्ट है. ठीक है, सो दिस इज पेयर्ड डेटा. So when you have paired data and you want to verify something, so what is the name? Name is signed rank test. That is the name. Now, if you assume that quality of life काउंसलिंग के बाद बढ़िया हो गई सबकी, तो क्या होगा? जो सेकंड कॉलम है उसका हर एलिमेंट फर्स्ट कॉलम से बड़ा होगा. तो अगर हम डिफरेंस ले लें तो सब पॉजिटिव आएंगे. डिफरेंस सेकंड माइनस फर्स्ट, ऑल विल बी पॉजिटिव. और मान लीजिए थेरेपी का कोई इम्पैक्ट नहीं पड़ा तो लगभग जीरो आनी चाहिए, और थेरेपी ने नेगेटिव इम्पैक्ट कर दिया, पागल कर दिया, और नेगेटिव आना चाहिए. ठीक है, तो साइन लेंगे, उस साइन में भी रैंकिंग करेंगे कि पॉजिटिव इम्पैक्ट कितने हैं, कैसे हैं, बड़े हैं क्या, छोटे छोटे. दैट इज द आइडिया. तो चूंकि आइडिया डिस्कस इसमें तो एसपीएसएस है, बट आइडिया हमने आपको बता दिया. दिस इज द आइडिया बिहाइंड दिस टेस्ट. जी, हमेशा ध्यान रखिएगा स्टेटिस्टिक्स में टेस्ट स्टेटिस्टिक डेवलप करने में कोई ना कोई प्रोसेस, कोई ना कोई आइडिया होगा. हम वो आइडिया आपको बता रहे हैं. तो यहाँ क्या हुआ देखिए, लाइफ स्कोर नेगेटिव रैंक्स लिखी 2, पॉजिटिव रैंक 7. मतलब जो नंबर्स पॉजिटिव थे उनकी रैंक 7 थी. साइज 1 था इसमें, मीन रैंक, सम ऑफ द रैंक, ये सब आपको दे दिया गया. आपका फोकस कहाँ होना चाहिए? ये सब तो दिया गया है, नीचे फोकस यहाँ आएगा, इसमें आएगा. क्वेश्चन पे क्वेश्चन क्या था हमारा? व्हाट वाज द क्वेश्चन? अगर जस्ट हम लोग क्वेश्चन पे वापस चलते हैं. व्हाट वाज द क्वेश्चन? बिकॉज़ क्वेश्चन इज ऑलवेज इंपॉर्टेंट. रिमेंबर, क्वालिटी ऑफ लाइफ स्कोर आर मेजर्ड बिफोर एंड आफ्टर थेरेपी. अभी क्वेश्चन तो पूछा ही नहीं, देखिए हम इसीलिए हम वापस गए थे, क्योंकि हम रिकॉर्ड नहीं कर पा रहे थे क्वेश्चन पूछा है कि नहीं. क्वेश्चन नहीं पूछा है, जानबूझ के नहीं पूछा होगा. आगे चलते हैं. अब आप बताइए क्वेश्चन क्या होना है? लाइफ थेरेपी हैज नो इम्पैक्ट, दैट इज नल हाइपोथेसिस. alternate hypothesis, it has positive impact, it has some impact, it has negative impact. तो नेगेटिव वाला बहुत लॉजिकल नहीं, पॉजिटिव वाला लॉजिकल है. नो इफेक्ट एंड सम इफेक्ट भी लॉजिकल है, पर नेगेटिव बहुत ठीक लगता नहीं. तो सबसे बेस्ट तो पॉजिटिव है, बट आप पॉजिटिव तक नहीं जाना चाहते हैं तो भी, तो आप जैसा भी करना चाहते हैं उसके हिसाब से यहाँ आंसर दिए हैं. सी आंसर फर्स्ट वन इज exact significance two-tailed. Two-tailed means if you focus upon this, you are saying that there is some impact. If you are saying that one-tailed, there is positive. Okay? So if I focus upon this 0.18, that means almost 1.8%, and this is almost 3.5% in both the cases. In both the cases, p-value is very low, even less than 5%. So it rejects the null hypothesis. That means there is an impact. So we reject the null hypothesis that the median of differences is same, as there is sufficient. Now, how if you reject it, how to write it down? There is sufficient evidence to indicate a difference in the distribution of life score after and before the therapy if you focus upon two-tail. Otherwise, what you should write down, there is sufficient evidence to indicate an improvement in the improvement after the therapy. Okay, that you have to write it down. So it depends upon What is your alternate hypothesis? Accordingly, you write down your conclusion. सर बताइए, रोक दें? क्योंकि इतना ही मेन हमने किया था, पैरामीट्रिक में यही किए थे, तो नॉन पैरामीट्रिक में उनके इक्विवेलेंट सारे करते हैं। अब इसके बाद जो होगा वो और अलग हो जाएगा। So I think I should stop here with one thing which is very important. पैरामीट्रिक वर्सेस नॉन पैरामीट्रिक, ये थोड़ा सा छोटा सा है। वन सैंपल टी टेस्ट आप लगा सकते हैं, तो उसके इक्विवेलेंट में साइन टेस्ट लगा सकते हैं। टू सैंपल टी टेस्ट तो मान विटनी साइन रैंक, टू सैंपल पेयर्ड विल्कॉक्सन साइन रैंक। पियर्सन कोरिलेशन अगर वहां हमने पढ़ाया होता तो यहाँ स्पीयरमैन हो जाता, वन वे अनोवा पढ़ाया होता तो यहाँ पर क्रिस्टल वालिस हो जाता, टू वे अनोवा पढ़ाया जाता फ्रीडमैन हो जाता। नाउ क्वेश्चन अराइजेस, वी हैव टू कॉलम्स, we have two columns, parametric and non-parametric, and in second column, if you see in this, we have two tests. Okay. Now question arises, if you have two sample independent, if you have two samples and they are independent and you want to test something, whether you should use this one or you should use this one or use this one. So parametric non-parametric में तो आपको क्लियर है, अगर नॉर्मेलिटी से आ रहा है तो पैरामीट्रिक में चलेगा, अगर नॉर्मेलिटी से आ रहा है नहीं आ रहा है तो आप इधर आ गए, तो इन दो में से कौन? That is again the question. Which one of these? So आप याद करिए, स्टार्टिंग में हम लोगों ने डिस्कस किया था, there was two types of error, type 1 error and type 2 error. Type 1 error you have fixed it. Type 2 error हमने आपको कहा था मिनिमाइज करते हैं. Okay, so what was type 2 error? Type 2 error was do not reject when it is false. So if I take the complement of it, reject when it is false. Okay, reject when it is false. So that means you are taking the right decision. Something is false, you are rejecting it. This is in statistics known as power of the test. Power of the test. Probability of rejecting null hypothesis which is false. गलत बात का अपोज करना ही पावर होती है. आप सब अभी तक समझ गए हो, तो फैकल्टी हो तुरंत समझ गए हो कि गलत बात का अपोज करना ही पावर है. किसी भी मीटिंग में जब आप बैठे होते हैं, आप कितने पावरफुल है वही पता चल जाता है. जब हेड कुछ गलत बात कहता है और आप एक्सेप्ट कर लेते हैं, शांत बैठ जाते हैं, इग्नोर मार देते हैं, तो आप पावरफुल नहीं है. इसी तरीके से स्टूडेंट्स के लिए, क्लास में पढ़ाते हुए टीचर से क्वेश्चन पूछा, टीचर ने डांट दिया, आंसर नहीं दिया, अब स्टूडेंट पावरफुल है कि नहीं वही पता चल जाएगा. पावर बड़ी इंपॉर्टेंट चीज है. So a test must be powerful. So if all the parametric assumptions are there, always use parametric tests because they are more powerful than the non-parametric. But if you are going to non-parametric, find out which test is more powerful. तो जो ज्यादा पावरफुल है उसे यूज करना है. That I want to also convey, and after that